Right, I'm going to demonstrate to you the need of next hop self, and next is we will see the authentication in BGP. Authentication in BGP. Alright, sorry for the handwriting, my pad is in wrong position. Next is about the peer group. So this is what our today's topic is going to be. Peer group is the fresh topic that we are going to learn. And next up self, and then authentication. You remember the previous class we discussed why we need fully mesh when we have some routers like this. If they are not connected through a LAN switch, if the topology is like this, then we learned that split horizon rule works. BGP split horizon rule works. So route learned from one IBGP will not be learned on another IBGP. That's what we learned. So here, let's say we got router 1. Let me see the topology. 2, 3, 4, 5, 6. We got router 2, router 3, 4, router 5, and 6. Now when we have something like this, and if the topology is like this, this is one autonomous system and these two are other autonomous systems, then what will happen is the route that is learned on an eBGP router, let's say we got here 6.6.6.6, this is learned on R3. R3 will give it to an IBGP. R3 and R4 are IBGP, but R4 will not give to R2. Likewise, R3 will give to R5 and R5 will not give to R2. Further, what we do is we also say R3 your neighbor with R2. Just forming neighbor with directly connected is not enough. We need to even form neighbor with R2. Doing so is called fully mesh. And similarly, if I want route from R1 1.1.1.1 to be seen on R3, I need to form neighbor with R3 from R2. R2 and R3 need to be a neighbor. Yes. Automatically. It works automatically. BGP by default it will have that split horizon. We don't turn off. There is no facility to turn off. So what we do is we make fully mesh. Alright. Now this is actually our topology is going to be, now we will have 12.0.0.0 network, 24.0.0.0. You know all the other stories how we will give the IP address. And we also learned one more. What is that? Next up self command. Why? When R3 advertises 6.6.6.6, it will advertise R6 address. Let's say here I got 36.0.0.6. So this will be the next hop address for 6.6.6.6 learned on R2, R4, R5 and R6. Sorry, R3. R3 knows where is 36. 36.0.0.6. R3 knows where is 36 because it is directly connected. So from R3 I am able to ping 666. But I am not able to ping from R4, R5, R2. The reason is these three routers don't know where the 36 is. The reason is we will not run OSPF here. No OSPF on that interface. Because it's two different autonomous systems, we don't run any routing protocol. Now, the good question is, can I write a static route? Yes, you can write a static route. If I write static route, see, I'm writing static route on R2, R4. In order to go to 36.0.0.6, go to router 3. If I write that, then I need not to say what? Next up self command. Next up self command is needed only when there is no route. So I make R3 to put its own address as the next up address, so that I need not to write static routes on R4, R2 and R5. Any one. But writing static route is not really okay. The reason is 36.0.0.6 is anyhow, it's not our network, it's someone's network. If I write a static route to reach 36.0.0.6, what if he changes the network or changes the IP address? Then no, all the static route that we wrote is waste and we lose the BGP updates. We will not able to ping the network 6.6.6.6. So it is better to change the behavior. Go to R3 and make R3 to put its own address as the next up address instead of carrying the eBGP's address inside iBGP. So these two things are very clear because we saw in the previous class. Now this class we are going to focus more on peer group. What is peer group? Now let's say we got one autonomous system here, one autonomous system here. So definitely I need to say next up self on R3, R4, R2, R5. Why? Whatever that is coming from R1, I need to change the next up self. I need to change the next up address. Whatever that is coming from this side to R4, if I want to learn those networks, I need to have next up self command here. So what we understand is we need to have in each router in this topology, how many iBGPs are there? 4 iBGPs are there. So on each iBGP router, we need to have 3 neighbor statement with remote AS. If I am on R2, I'll say R4 as neighbor, R3 as neighbor, R5 as neighbor. All these 3 belong to where? AS, let's say this is AS20. So I'll say remote AS20, remote AS20, remote AS20. Next what I need to do is, for all these 3 again, I need to say 4 next up self, 3 next up self, 5 next up self. And in case if I am using loopback interface address as the neighbor, what is needed? Update source command. So again 4 update source loopback 0, 3 update source loopback 0, 5 update source. So I need to write what? 9 statements. 9 statements I need to write on each router. Now if I have 50 neighbors, I need to write 49 into 3. Instead of doing that, instead of writing this many lines, I can create peer group. What is peer group? Peer group helps us to create a template. It helps to create what? Template. It helps to create a template wherein we will say this thing common. We have what? Remote AS20 is in common for every neighbor. So we will say only once in a template name called ABC 20. And then in every router we said what? Next up self, next up self. So we will say once next up self. And then update source loopback 0. We will say once update source loopback 0. And then we will call this template for router 4, for neighbor 4, for neighbor 5 and for neighbor 3. When I call this template ABC on R4, all these 3 are added. Single time processing. It even utilizes process less. I'll bind this ABC on 5. So all these 3 are added. I'll bind this to 3. All these 3 are added. So now how many lines? For template we wrote 4 lines. And this is one neighbor, this is another neighbor, this is another neighbor. Totally 7 lines we have written. If I don't know peer group, how many lines I need to write? 9 lines I need to write. You may say, what? Peer group saves only 2 lines. No, it's not really saving 2 lines. Think about 50 neighbors. If there are totally 50 IBGP routers, we need to write 49 into 3. Here in our case, we have only 3 things in common. It's a big number. But if I have a template, when I call this template for 49 neighbors, done, work done. So 49 plus this 4 lines, 3 plus 1 peer group, 4 lines. Just in 53 line of code, we finished our configuration. So peer group is really good. It saves our line of code plus process utilization. How process utilization? When I call this template, just in single processing, all these 3 are added, not separately. CPU utilization is also less. So these are the things that we are going to focus on today's class. Let's quickly get into action. Here we got those routers we were discussing. Before I put in the box, let me connect the cables. I'll connect maybe fast Ethernet to this serial. It can have any cables. Got it, right. Now to explain this thing, this is the only topology that anyone can have. If I add more routers, then there is no point of adding more routers. To explain this thing, 4 router is what needed in the middle. If it is router 5, I have loopback interface with address 5.5.5.5. Similarly, router 4 has 4.4.4.4 and 3.3.3.3. Now here, because we have redundant paths to reach, say R2 can reach R3 in 2 different paths. One via R5 and another via R4. So we will use loopback interface as the source. Now assume that R5 is also connected to some other autonomous system. R4 is also connected to some other autonomous system. So we need next up self even on R5 and R4. Alright, assuming that we have autonomous systems connected even on router 5 and router 4, we are going to do. Now on R1, this is autonomous system 10. This one is autonomous system 20. And we also need to run OSPF, process ID 1, area, any area, I'll put 0. And in here we will have AS 30. Okay, I'll quickly use Notepad so that configuration will become faster. Let's start from R5. Enable config T interface loopback 0. IP address is 5.5.5.5, 255.255.255.0. I'm saying /24. And then interface serial 1/0, no shut. IP address is 25.0.0.5 255.255. Let it be slash rate 0. Interface serial 1/1. No shut. IP address is 35.0.0.5. Okay, I want to enable OSPF parallelly. See, you know how to enable OSPF. IP OSPF 1 area 0. Interface level configuration. Okay, OSPF is done on this 3 interface. What else? That's all. I'm not going to enable BGP now. We'll do it later. Let's do only basic configuration. So I'm going to copy all this and paste it to router 5. It is done. Similarly on router 4 we got 4.4.4.4 and serial 1/0 will have 24.4 and serial 1/1 will have 34.4. That's all. I'll copy this and paste it on router 4. Okay. Router 4 is also ready. Now let's finish 2 and 3 and then we'll do router 1 and 2. 1 and 6. Let's finish 2 and 3. So router 2 has got one more additional interface, so I'll add it here. Interface fast Ethernet 0/0. No shut. IP address is 12.0.0.2 255.0.255.0.0.0. So this is the address on R2's interface. So this we are writing for R2. R2's loopback interface will be 2.2.2.2. Serial 1/0 will have 25. Serial 1/1 will have 24. That's all. And we are not going to run OSPF. Look at this. We are not running OSPF on fast Ethernet because that is connecting to another autonomous system. We are not. All right. Pasting this on router 2. So it is done. Now one more router with similar interface. So this will have 36.0.0.3 and serial 1/1 will have 34.3. 1/0 will have 35.3 and loopback will have 3.3.3.3. all right, nothing more on R3. Right, two more routers with just two interfaces. So I'll delete the serial one. Alright, loopback interface of router 1 has got 1.1.1.1 and fast Ethernet has got 12.1. No OSPF, no protocol here. Copy, paste it on router 1. One last router, 6.6.6.6. This will have 36.0.0.6. No routing protocols. Pasting it on router 6. Alright, so what do we have here? The basic configuration. Now let's start with BGP. First of all, let us finish eBGP between R3 and R6, R1 and R2. Now I am on R6. I'll say router BGP 30. Neighbor is 36.0.0.3. Remote autonomous system is what? 20. Now, very important. I want to advertise the 6 network. So I say what? Network command. 6.6.6.6. Sorry, 6.6.6.0 mask. Why? It is not default mask. 24 is not default. So I need to say the mask, exact mask. Done. If it is 32, I would have said 6.6.6.6. Instead of 0, I would have put 6 here, and then I would have said mask 255 completely 255. All right, now this is what need to be done on this router. It is done. Let's verify. Show IP BGP summary. When you type in this command, you should see the neighbor that you added. R3 is the neighbor. But this neighbor has never come up. Why? Because R3 is not configured with R6 as a neighbor. Both should have neighbors configured. So it is in idle state. Still it is idle. It is not able to establish peer. Alright, so far no messages sent nor received. This neighbor belong to what autonomous system? 20. What is this router belong to? This router belong to 30. Now BGP also uses ID like OSPF. See, it has picked the loopback interface address as the router ID. Now let us see what network this BGP is advertising. To see that, show IP BGP command. See, it shows that 6.6.6.0/24 network is advertised from here. What is the next hop for this network? No next hop. I myself is the next hop. That's why 0.0.0. See, R6 has its own network called 6.6.6.6. It is not learned from someone. So next hop will be 0.0.0.0. Alright, now it is valid and best. If you have star, it is valid. If you have greater than symbol, then it is best. It is valid as well as best, and this is what advertised from this router local 0.0.0.0. Now let us go and form neighbor between R3 and R6. So I'll go to R3 and configure BGP. Config T, router BGP 20. Who is the neighbor? Neighbor is 36.0.0.6. Remote autonomous system is 30. What else? That's all. I don't want to advertise any network from R3. Now I should form neighbor. I will form neighbor. Yeah. BGP adjacency is formed and it is up. BGP will be little slower than other protocol because it's a TCP protocol. Now, if I go back to R6, I'll see some changes there. On R6, you see I got neighbor up, and if I type show IP BGP summary, I see that neighbor is there up for 27 seconds. And so far 4 messages has been received from the neighbor and 5 messages has been sent from this router. Now I would like to show you something here. Show IP BGP neighbor. You see, it's the same information. It says neighbor is established for last 41 seconds. This is the router ID of the neighbor router. I am on R6. R6 is showing the neighbor's router ID. And so far 5 messages has been sent. In that, one of the messages is called open message, which is sent initially, and then 2 update messages, 2 keep alive messages. So in total it is 5. Like as here, we got 1 open message from the neighbor initially and 1 update, 2 keep alives, so totally 4. And one more time. Right, so there are many more information that you get from here. I'm interested in this. Look at this. Because it's an eBGP neighbor, the outgoing TTL will be 1. If it is IBGP neighbor, outgoing TTL is 255. That's why IBGP neighbor need not to be directly connected. They need not to be directly connected. They can be anywhere, provided they are reachable. Because it's TCP 179. See, it uses TCP port number 179. Alright, so let's go to R3. You're going to see some difference here. When I type show IP BGP summary, I am seeing a number here, 1. But when I see the same command on R6, I don't see that number. You see, on R6, when I type the same command, I'm seeing 0. Whereas in R3, I see a number. What this means? This means that from this neighbor, I have learned, or I have received, see RCD, I have received a prefix. I have learned a network. What is the network? We all know that we advertised 6.0, 6.6.6.0 from R6. So that one network that it has learned, that's why it is showing 1. Now I want to see what it is learning. So type show IPBGP. When I type show IPBGP, I can see what I am learning. Say I'm learning something called 6.6.0.24. From whom? From the next hop 36.0.0.6. Is this a reachable address? Yes. Now from where I'm learning it from autonomous system 30. See, this is 30. This is why we call it as path vector routing protocol. BGP is a path vector routing protocol. Why? It shows the path through which it learns the neighbor, plus it picks the lowest shortest AS path. If I have multiple paths to reach a destination, it picks the path with the lowest or less AS in the middle. Okay, now we learned 666. Let's check whether it is valid and best. Yes, it says greater than, and see here, greater than and the asterisk, which means valid as well as best. Now if the routes are valid and best, only then I'll see the route in the routing table. You see, the routing table says that through BGP I have learned 6.6.6.0. Now you see the administrative distance is 20. Why? Because it is eBGP. Now because I got the route, I can ping now 6.6.6.6. I'm able to ping and I get the response. Now let's finish the authentication. I'm going to enable authentication between R3 and R6 BGP. How to do that? Router BGP 20, neighbor 36.0.0.6, password anything. Now I should lose my neighbor now. The neighbor should go down. It will go down. Every 60 seconds only they send the keep alive, so it will take some time. You see here the timer, not this one. The neighbor will expire now. Show IP, or let's do one thing, debug IP BGP all. See? No, this is not showing. Let's wait. We can wait, or if you want the immediate result, we can clear the neighbor. This is how we can reset the neighbor. Clear IPBGP. You can type the neighbor address, or you can also type all, or all like this, all. If I do that, what will happen? If I type in this, what will happen is it will terminate the neighbor and re-establish. Instead, if I say soft, it won't terminate the neighbor, but it will do re-establishing the neighbor. I'm saying soft this time. Okay, see, because I said soft, it is sending a refresh request, and let's see, at least now it is finding the authentication missing. Show IPBGP summary. Okay, let's do hard reset, no other go. Debug, sorry, not debug, clear IP BGP start. I'm doing hard reset. Yes, look at this. This says open failed. I'm expecting something more. Active, open failed, open active, again failed. So if I go to the opposite router, it will show you very clear information. MD5 is missing. This neighbor is not sending the authentication. It's not sending with authentication. MD5 is the authentication type that is used. So the opposite neighbor is not sending with authentication. No MD5 message digest. Alright. Now let us go and put authentication on this router. Router BGP 30. Neighbor 36.0.0.3. Password is anything. Now I must see the neighbor coming up. See, this should stop now in some time. It will stop and say neighbor adjacency formed. Yes, the neighbor has come up. No more this message. It won't show anymore that message. Alright. So quickly I'm going to do the same thing between R2 and R1. Let's do it a bit fast. So R1. Meanwhile, I'll use the notepad. Enable config T router. Router BGP 10. Neighbor 12.0.0.2. Remote autonomous system 20. Network command 1.1.1.0. Mask 255.255.255.0. We must match with the mask on the interface if it is subnetted. What else? If you want password, I can say neighbor 12.0.0.2. Password 12345 ABC. That's all. And write to memory. So similar configuration I will also do on R2. So let me finish R1 first. Okay, R1 is done. So on R2 how we will do? 12.0.0.1. Here the autonomous system is 20. Now 12.1 belong to what? 10. I don't want to advertise any network from R2, so I delete this, and the password with 12.0.0.1 is the same. Copy and paste it on router 2. Alright, so I'm going to paste this and we will see neighbor getting formed between R1 and R2. Okay, BGP is up. Now if I type show IP BGP summary, look at this, I can see neighbor is established with 12.1 and Still I have not learned any network. Why? Keep trying. It may take some time for the update to come. So before that, I want to go and check whether R1 is advertising it first of all. R1. How to check? Show IP BGP, that's all. This shows that it is advertising, but it is not best. It says I'm advertising 1.1.1.0/24, but it is just valid. Why it is saying like this? Okay, now it took some time for it to decide as a best. Now because it is best and valid, definitely this will be seen as the update on R2. So look at this, we got 1. Now on R3, if I type show IP BGP, show IP route, let me see only BGP route. See, I can see 1.1.1.1. Now if I ping from here 1.1.1.1, I'm able to ping. Alright, now this is about eBGP and the authentication. Now let's talk about peer group. You see, on R3, how many neighbors I need to, on R2, how many neighbors I need to make for iBGP? 3 neighbors. One with router 5, other with router 3, another with router 4. And all these routers are having redundant paths, so I'll be using what? Loopback interface. So configuration will go like this. Let me use a notepad. Configuration will go like this. Neighbor. What is the neighbor for router 5? What is the neighbor address of router 5? For router 2, router 5 is neighbor. I'm going to use the loopback interface of router 5. And what is the remote AS that router 5 belong to? 20. I don't want to have any authentication, so let me remove this. And with that neighbor 5.5.5.5, I want to say update source as my loopback interface 0. So what I'm saying is, whenever this I am writing for router 2, I'm saying router 2, whenever you send any update to router 5, put the IP address on the loopback interface 0, which is 2.2.2.2, and send. Okay. Similarly, I need to do it for how many neighbors? Other 2 neighbors. So let me copy this. For router 3, done. And again for router 4, done. Now what I'm going to do is I'm going to copy this and paste it. See, still I have not done next stop self. I want to show you if we don't have that, what will happen, and if we have it, what is going to be the change. So these things we already discussed, so I'm doing this. Next stop self we have discussed, but I'll do it after finishing this basic BGP configuration. Now similarly on router 5, I need to do what? 2.2.2.2. Right. So I'll paste this on router 5. Router 5 has got 2, 3, 4 as neighbor. Router 5. Done. On router 4, what I need to do is I need to say 5, 3 and 2 as neighbor. Router 4. Now one last router, router 3. On router 3 I need to say 2, 4 and 5. Okay. Now we got fully mesh. Because of that, router 3 will have 1.1.1.1. Will it have? No. It will not have. No, it will have, because now it is fully mesh. It will have only in the BGP table, not in the routing table. I want to show you that. See, show IP BGP summary. We got 3 IBGP neighbors. One is eBGP, that is 36. These 3 are IBGP neighbors. From these 3, only from one guy I am learning something. Okay, I am learning something from 2.2.2.2. Why? Why I am not learning from router 5 and 4? Why I am not learning from router 5 and 4? Spread horizon. What is that I am learning from 2.2.2.2? I am learning 1.1.1.1 from 2.2.2.2. I am not learning from router 5 and 4. But if you go to router 4 and 5, you can see that 1.1.1.1 show IP BGP. You see? 1.1.1.1 is there. Show IP BGP summary. 1.1.1.1 is learned from router 2 here. But this guy is not giving to whom? To router 3. So who gives to router 3? It is R2 giving to router 3. R2. It's coming from R2 directly. Okay. Okay. Now, let's see. Show IP BGP. I got 1.1.1.1, but it is not best. I am not seeing that greater than symbol here. Because I don't see that, when I type show IP route BGP, I don't see the route in the routing table. Sorry. Show IP route BGP. I'm not seeing 1.1.1.1 in the routing table. If you don't have in the routing table, then you cannot ping. Show IP route, show IP BGP. I got as a BGP update, but in the routing table, I don't see that. You know the reason why? This address is an unreachable address. See, I'll ping and show you. For router 3, it don't know where is 12. Why? We don't run OSPF there. Cannot ping. So it has the next hop address as an unreachable address. So what is the solution? I need to go to router 2 and say, I myself is the next hop. I'll show you that. Only then you will see in the routing table. Only then this will become best. Now go to router 2. Router BGP 20. Neighbor 3.3.3.3. I myself is the next hop. Not only to router 3, we need to say this for every router. I myself is the next hop. Next hop self. When I say this, now you can see router 3 having wait some time. See, it's still 12.1. Wait for the update. Still 12.1. As long as it is 12.1, you will not have greater than symbol there. It needs to change from 12.1 to 2.2.2.2. Yes, you see, it took some time. Now the next hop address has changed. This is a reachable address. You see, you can ping this. Because it's a reachable address, you got best. Now, show IP route BGP. I can see the route in the routing table also. But it is what? 200. Why? Learning from an IBGP. If you learn from eBGP, the administrative distance is 20. If you learn from an eBGP, if you learn from an IBGP, it is 200. If you learn from eBGP, it is 20. Now, what about router 5? Do they learn? They don't. See, show IP route BGP. They don't learn anything in the routing table, but in the BGP table, show IP BGP, they have both. The problem is 12.1 is also unreachable for router 5. 36.6 is also unreachable. So what I need to do? I need to go to router 2 and say next up self, not only for router 3, for router 5 and router 4. Plus, I need to go to router 3 and say next up self for router 4, 5 and router 2. So repeatedly I need to say what, on all this neighbor, I need to add one more line. On all this router neighbor 2.2.2.2 next hop self. Next hop self. So this has to be given on every router for every IBGP neighbor. So now how many neighbor statements we got? Actually we got only 3 neighbors, but you see the neighbor statement 1, 2, 3, 4, 5, 6, 7, 8, 9. But these 3 are repeated again. Next hop self, next hop self, next hop self. Update source loopback 0, update source loopback 0, update source loopback 0, remote AS20, remote AS20, remote AS. So instead of repeating the same thing again and again for each neighbor, we can use what? Peer group. Now I'm going to show you the peer group. Before that, let us go and cancel all the BGPs in this router. I'm going to cancel BGP on all these 4 IBGP routers. So let me use here in the space. Enable config T router BGP 20. What I should say? No. Right, end write to memory. So I'm going to cancel BGP on R2, R5, R3 and R4 so that we can see how eBGP works. Peer group works. Done. Router 3 BGP is cancelled. Router 2 BGP is cancelled. Let us do it on router 3. And router 3 is also done. 4 done, 5 done. Now even we lost what? eBGP neighbor. Now let's do eBGP neighbor plus peer group. Now see, this will be a good revision for you. Router BGP 20 on router 2. This I am writing for router 2. eBGP neighbor we need to write manually. So I'll say neighbor 12.0.0.1 remote AS what? 10. There is no change in that. But for IBGP, what I'm going to say is neighbor, give any name. I'm going to say ABCD peer group. I'm saying ABCD is a peer group. You see, I'll show you in the router itself. In one router I'll do, and then other routers I'll copy and paste. See, router BGP 20. Let me copy and paste this. And then for IBGP neighbor, what I say? I say neighbor, give any name, ABCD peer group. That's it. After that, neighbor, ABCD remote AS 20. Neighbor, ABCD update source loopback 0. Neighbor, ABCD next hop self. You see, 3 lines. Let me copy this to the notepad. These are the 3 things that we will be repeating again and again for all the neighbors. Even if I have 100 other neighbors, if I'm going to repeat these things, I can create a template like this. We can create a template like this, and then I can call this template for each neighbor. How? Let me show it on router once. Neighbor 5.5.5.5 ABCD peer group. Peer group ABCD. That's it. Now all those 3 things are added. Which 3 things? These 3 things that I mentioned. All these 3 things, not 3 things. Yeah, these 3 things are added to that neighbor 5.5.5.5. Similarly, the other 2 neighbors. Who are the other 2? So after 5 is done, let's say 3.3.3.3, and one more is 4.4.4.4. This is what called as peer group. So you see, even the line of code is less now. We got 3, 4, 5, 6, 7, 8 line of, sorry, not ABGP, 7 line of codes. Previously we were having 9. For IBGP itself we were having 9. Now it is 7. Now it will be really big difference if it is huge network, if it is a big network. So I'm going to paste this once again on router 2. Done. So router 2 is done. Let's do for router 5, 3 and 4. So for router 5, I need just to change a little bit. That's it. This is for router 5. I'm sorry, for our router 5, this EBGP neighbor is not needed. So remove this. Okay, router 5. Same template. Pasting. And now router 4, I'll just change this as 5. That's the only one missing. Right, so this is for router 4. And for router 3, I'll take this 3 out and then put 4. That's all. Peer group is over. All 4 routers are configured with all necessary configuration like next hop self, update source, and the neighbor statement. Okay, now you're going to see router 3 saying I got 3 IBGP neighbors. Just a minute. You see, we got 3 neighbors. But in here, I need to say one eBGP. So I'll say router BGP 20. Neighbor is 36.0.0.6. Remote AS is what? 30. That's it. Now, because we said next hop self, update source, everything. Now I should see on R3 show IP BGP. I should see 1.1.1.1 as valid and best. Give some time, it will come. Just now we enable, so it will take some time. Let's go to router 2 and check whether it is learning. Show IP BGP. Then there is some problem. Show IP BGP summary. Okay, this is not forming neighbor. Why? 12.0.0.1. Remote AS is 10. 1 minute. Why? Let's try pinging 12.0.0.1. This is pinging. Then we should form neighbor. Show IP BGP. I'll not get unless and until I find neighbor. I'll not get. Maybe I'll go to router 1 and refresh. Okay, authentication. Yes. You remember we enabled authentication on router 1. So what was the authentication? The password was 1234 ABC. Okay, that's why I didn't find neighbor with R1. So let's do it. Router BGP 20. Neighbor is 12.0.0.1. Password this one. Okay, now I should form neighbor with R1. Yes, we got neighbor. So if I type show IP BGP here, I will see, you see 1.1.1.0 here. Now I'll go and check whether I'm learning the same on router 3. Go to router 3. I'm learning. Now why I'm not learning 66666? Same problem. Password between R3 and R6. So I'll say router BGP 20 neighbor 36.0.0.6 password anything. Alright, I am expecting neighbor as well as an update from R6. Okay, neighbor has come. Show IP BGP now. You see, we got both 111666 and both are valid and best. Because it's valid and best, show IP BGP, show IP route BGP. I'm seeing the routing table with BGP update. You see, we got both. On every router you can see that. Go to router 5 and check it. Show IP route BGP. We can see that. Now let us go to router 6 and check. Show IP route BGP. You see, on router 6 we are learning this. We are learning it. We are learning the network from the left. Now if I ping from here 1.1.1.1 with the source of 6.6.6.6. You know why I am sourcing with 6? Because if I just ping without source 6666, my exit interface address will be the source address, which is not known by R1. R1 don't know anything about 36. We are not advertising it. We are not using network command and advertising 36. We are advertising only 66.6.6. Now this ping will definitely happen. You see, we are able to ping from right to left. Right. Similarly, if you go to router 1 and ping 6.6.6.6 source my loopback 0, which is 1.1.1.1, I am able to ping. It will ping. It pings. Now the packet loss in the middle, you know, some packets are getting lost. It's not because of the BGP. It is because of my GNS, the process utilization in my PC. Okay, so it works. Now we have learned a lot of foundational thing. Tomorrow is going to be our big class. Like, you know, we are going to talk about attributes. Before that, let me show you one more thing. Show IP BGP. You can see here that 6.6.6.0 is learned is coming via AS20, and that AS20 is learning it from 30. That's why it is called as path vector protocol. It shows the autonomous system path through which this update is reaching this router. Path vector routing protocol. Hope you understood this. Go through this video once or twice and until you get some good understanding about what all we discussed so far. And come tomorrow, we'll discuss about BGP path attributes. Thanks for joining. See you tomorrow.